In a large retail warehouse on the edge of a city, the movement of people begins before any product is picked up. The entrance opens into a transitional space wide enough to absorb incoming flow, structured enough to direct it. At the boundary between outside and inside, rows of metal carts are nested together, aligned in long sequences. Customers approach, separate one cart from the stack, and enter the store, already connected to a system of movement, capacity, and expectation. The carts here are not arranged randomly. Their dimensions are consistent across the entire store, and often across different branches of the same retail chain. Even when designs vary slightly, wire density, handle shape, wheel, material, the overall size remains within a narrow range. This consistency is not a design preference. It is the result of a system that depends on predictability at multiple levels. Inside the store, aisles are spaced with a specific width that assumes the presence of these carts. Two carts should be able to pass each other without interruption, while still allowing a person to stop and reach for a product. This spatial balance is not recalculated for each location. Instead, it is standardized early in the planning process based on the expected dimensions of the cart. The cart becomes a reference unit not just for carrying goods, but for structuring the environment itself. This relationship extends beyond aisle width. Shelf height, product depth, and display angles are all influenced by how far a person can reach while holding onto a cart. The cart defines a physical boundary between the shopper and the store layout. Its length determines how close one can approach a shelf. Its height influences how items are placed vertically. Over time, these interactions stabilize into repeatable patterns. Designers no longer question the size of the cart. They design around it. The standardization process does not begin inside the store alone. It connects to logistics systems that operate behind the scenes. Products arrive in uniform containers, boxes, pallets, and crates that are themselves standardized for efficient transport. When these goods are transferred from storage to shelves, their dimensions align with the space. A cart can reasonably carry. A cart that is too small would require more trips. A cart that is too large would disrupt movement and reduce accessibility. The chosen size reflects a compromise between capacity and maneuverability, but once established, it becomes fixed through repeated use. Procedures reinforce this stability. Store operations are built around assumptions of cart behavior. Cleaning routines, for example, are scheduled based on how many carts circulate through the system. Storage areas are designed to hold a specific number of carts within a defined footprint. Even the slope of the parking lot outside may be adjusted to prevent carts from drifting too easily based on their weight and wheel configuration. Over time, these procedures accumulate into a form of institutional memory. New stores are built using templates derived from previous locations. Equipment suppliers manufacture carts according to specifications that match these templates. Maintenance teams are trained to repair standard components rather than adapt to variation. The system becomes resistant to change, not because alternatives are impossible, but because the cost of altering one element would require adjustments across many others. The cart's size also interacts with patterns of human behavior, but not in a way that is individually tailored. Instead, it reflects aggregated observations. Retail environments track how much customers tend to purchase in a single visit. These patterns influence decisions about cart volume. A larger cart may encourage more items to be collected, but it also increases the physical space required to navigate the store. A smaller cart may limit purchases but improve flow. The standard size emerges from repeated calibration. Between these competing factors, this calibration is not continuously adjusted in real time. Once a workable balance is found, it is preserved through standardization. Changing the size of carts would require recalibrating aisle spacing, checkout design, storage capacity, and even transportation systems that move carts between locations. Stability becomes more valuable than optimization. The system favors consistency over local variation. Checkout areas provide another point where this standardization becomes visible. Conveyor belts, bagging zones, and payment terminals are positioned with the assumption that a cart of a certain size will approach them. The distance between the cart and the cashier the angle at which items are unloaded, and the space available for packing all depend on this shared reference. If carts varied significantly in size, these interactions would become less predictable, slowing down the process and increasing friction. Beyond the store interior, the cart continues to operate within a broader infrastructure. Parking lot cart returns are spaced to accommodate the same standard dimensions. Transport vehicles that collect and redistribute carts are designed to stack them efficiently. Even escalators and travelators in multi-level stores are engineered to support carts of a specific width and wheelbase. Each of these elements assumes that the cart will conform to a known size. The persistence of this standard is not enforced by a single authority. It emerges from coordination across multiple actors, retail chains, equipment manufacturers, logistics providers, and architectural planners. Each operates within its own constraints, but they converge on a shared specification because it reduces uncertainty. When a new store is built, it does not need to redefine the cart. It adopts an existing standard that already aligns with established practices. Over time, this convergence creates a feedback loop. The more widely a particular cart size is used, the more systems are built to accommodate it. The more systems depend on it, the harder it becomes to change. What began as a practical decision becomes embedded in the structure of the environment. This does not mean that all grocery carts are identical. Variations exist: smaller carts for urban stores, larger ones for warehouse-style retail, specialized carts for bulk items. However, even these variations tend to cluster around a limited set of standardized sizes. Each category establishes its own internal consistency, allowing the surrounding systems to adapt accordingly. The stability of cart size is therefore not a static condition, but a maintained equilibrium. It is sustained through repeated use, reinforced by procedures, and embedded in physical design. When customers enter a store and take a cart, they are participating in a system that has already been calibrated. To support that interaction, the cart does not draw attention to itself. It operates as a background element, shaping movement without requiring explicit awareness. Its size feels natural not because it is inherently optimal, but because the environment has been built to match it. Over time, this alignment becomes invisible. What remains visible is the continuity of the system. Across different locations, the experience of moving through a grocery store remains largely consistent. The cart fits the aisle leads to the shelf aligns with the reach of the shopper, and the checkout accommodates the cart. Each element reinforces the others. This continuity is what allows the cart to function reliably in everyday use. Its standard size is not simply a feature of its design, but a condition of the system it supports. As long as the surrounding structure's spatial layouts, operational procedures, and logistical networks continue to depend on that size, the cart will remain as it is, quietly, maintaining its role within a stable and repeatable environment.